Okay, in this video we go over another diagnostic test. Anytime you apply regression, you need to be careful that you don't misapply it or do something that you should not do. One of the very important diagnostics when you're model building that you need to be considered is to be aware of multicollinearity. Multicollinearity is when you have independent variables, your x's, that are so closely related that when one changes, the other one changes also. If that exists, you should not have them both in a regression model, because in a regression model, one of the assumptions is that they are not related, they are independent. And then the misapplication would occur when you handed that model over to someone else and they were using it to predict. Then they would be allowed to freely change one of those variables independently of the other, which the data that the model was based on, that never happened. So you would have a huge the prediction, the forecasting model would be way off, your regression model would be way off if you modeled multicollinearity variables. Okay, so let's just show you what I mean by that. Here's a kind of a silly example, but let's work our way through it. We're trying to predict how tall someone is as a function of how big their foot is. So I've measured people's feet, but not only did I measure the right foot, I also measured the left foot. Well, that's possible. You can see what the problem is that the right foot and the left foot are going to be really, really highly correlated. So let's go ahead and do it, even though it's kind of silly. Let's go ahead and build a regression model where we're predicting the height as a function of both the right and left foot. And I'm going to generate, there's the data. Now let's kind of work our way through what it says. What's a good model? R squareds are high. Let's go down and interpret the output. If you look at this, it says the right foot adds to the height. The left foot actually makes you shorter. The right foot is statistically significant because this p-value is less than 0.1. The left foot is statistically not significant. Well, what's up with that? That almost doesn't make sense. More importantly, if you would use this to predict how tall someone was, if I had if we wanted to use this model to predict, and this is the misapplication, let's see. So if our right foot length, I don't even know what these measurements are. Let me, 12, 13, 14, okay. So if the right foot was like 12, whatever the units of measure, and the left foot, because it's allowing me to put these in independently, I could do something like that. Well, that's the problem with using data that's highly, that has independent variables that are highly related or correlated, because it would be the intercept plus sum product of these two. And I could change these independently, and we don't want that to happen. So how do I know if something is correlated? Because that's what multicollinearity means. Multicollinearity means that my independent variables are correlated. How do I know that? Well, I could always, before I do regression, I could do a correlation analysis. I'm going to look at the correlation between my right and left foot. And look at that. I've got a really, really high correlation. If your correlation is over 0.9, then that means you need to take action. The independent variables have a correlation coefficient that's greater than 0.9, then take action. Take action usually means remove one of them, remove one of the independent variables, or you could take the average of those. So use a average, use an average of the two. There's different ways that you can convert this to a single independent variable, either by removing one or trying to come up with a way that's a formula of both of those. Okay, thanks.